Okay, for question 1, right, the equation of L1 and L2 are 1 plus 3 lambda, 5 plus 2 lambda, 12 minus 2 lambda, 1 plus 8 mu, 5 plus 11 mu, and 12 plus 6 mu. Okay, where lambda and mu are real parameters, so you need to remember that lambda and mu are real. We want to show first state the position vector of the point of intersection P between line 1 and line 2. Okay, so take note, here there's a word state. And then if you look at the mark allocation, it's only 1 mark. It means that most likely, like, quite easily you can see you're able to see the solution right away without having to do much working. So what some students do is they actually blindly go and equate the find three equations and then start equating, and they realize that the point intersection is actually already there. Okay, so all you need to do is you just need to write out for line 1 and line 2, right, if you this is in the so-called the not implicit form, but if I rewrite my equation, right, line 1 can actually be rewritten in this form, which is just to write it as 1, 5, 12, means I separate out all the constants together with lambda, 3, 2 and negative 2. Okay, and lambda is real, together with line 2, and line 2 will be just be equals to 1, 5, 12 plus mu of 8, 11 and 6, where mu is real, right? So from here, right, if I were to list out a point of intersection, you can see that actually what is it? It just equals to 1, 5, 12, right? So you can see both points, both lines have the points 1, 5, 12. So very quickly you see that's the 1 mark, 1, 5, 12, right? That is the position vector of the point intersection. Very quickly, you can just put OP equals to 1, 5, 12, right? And that, you see, that's the position vector of the point of intersection. So OP is the, remember you are finding the position vector, so write your answer in the column form, alright, not the coordinate form, right? Okay, next up will be part 2. Okay, part 2, we need to find equation of the plane which contains line 1 and line 2 in the form of r dot n equals to d. Alright, line 1 and line 2, so if you are not sure, what you can do is you just draw it out. You can draw it out. This is your plane, plane 1, let's call it plane 1. It contains one line, so I'm just going to draw, okay, line 1. So line 1 looks like this, right? Remember it's 1, 5, 12, and then it's 1, 5, 12 plus lambda 3, 2, negative 2, right? Then remember there's another point intersection, right? There's line 2, right? There's 1, 5, 12 as well, 1, 5, 12 plus mu of 8, 11 and 6. Okay, so what can you say? You can straight away see that this plane, right, remember, because these two lines, right, these two lines, they lie on the plane. These two lines, they contains, this plane contains line 1 and line 2. Right, so what does it mean? You can see that if I were to ask you for a direction vector of line 1, what is it? It's just 3, 2, negative 2. Right? Another direction vector that lies on the plane will be 8, 11 and 6. Alright? What can we do with this? Alright, so what we need to do? Simple. We just take the two direction vector of the line, we do vector product. What will that give us? Remember, if you take these two, you cross, that's going to give you the normal of the plane. Right? Because you take A cross product with B, you're going to get a normal vector, the vector normal to A and B. So that's what we'll do. Doesn't matter which one you choose, so just consider, just take n equals to 3, 2, negative 2, you cross with 8, 11 and 6. Right? So I'm going to leave you to do this by yourself. Eventually you are going to get 34, negative 34, okay, and 17. Alright, this will be your normal vector. Alright, so do we have to take the whole magnitude? Is it possible to simplify? So always have the good habit of simplifying. So actually your normal vector, if we find a normal, right, we can just choose the normal to be, 2, negative 2, 1. Right, because it's just a scalar multiple of, we don't need to take the actual vector. Right, so this is a normal to plane 1. Simply by taking the cross product of the direction vector of line 1 and line 2. Okay, So next up, what do we need to do? We need to find the r dot n, the equation of the plane. Okay, so very quickly, r dot n equals to d. Now we take r dot n. D is just equals to a dot m, right? So we have n so far, right? Remember n, as we have found earlier, this is just 2, negative 2, 1. This is just 2, negative 2, 1. What is a? A is the position vector. A is the position vector, okay, of a point that lies on the plane. What is a? Look at this question, you can see, simply I can just take a as 1, 5, 12, right? So this is just 1, 5, 12. Remember, a 1, 5, 12 lies on both lines which lie on the plane. So 1, 5, 12 is a position vector of a point that lies on the plane. Okay, so with that, this is r dot n. We can quickly write our answer. It's 1 and 2, 5, negative 12, negative 2, 12 and 1. Eventually, you are gonna get 4. Right, 2 minus 10, let's say, okay, so it's 4. Alright, next, so the equation of the plane is none other than 2, negative 2, 1 to be equals to 4. And this is your answer for part 2. Okay, this is your answer for part. So do take note. A lot of students, they will forget to factorize out. So for example, this, what a lot of students do is a lot of them forget to take out the 17. Right, so some of you may get answer something like this. You may get something like 34, negative 34, 17 equals to 68. That is, you will forget to factorize out the n, but that is fine. Just that it's not an elegant answer. When your coefficients are very big, it's hard to use it later on. Alright, so always try to simplify wherever possible. The normal can be simplified. Alright. So next, we're going to do part 3. For part 3, right, what I want to do, we need to show, okay, slowly, okay. The point Q has position vector 4, 0, 8. So we can see this as 4, 0, 8. And the line through Q, perpendicular to plane 1, meets plane 1 at R. Alright. The line perpendicular to Q meets, okay, perpendicular to plane 1, meets plane 1 at R. Alright, so what do we do? Okay, first what I can do is I can draw the diagram. Alright, so for Q, the line passing through Q meets plane 1 at R. Right? So that's basically what they're gonna do is they just want you to find the foot of perpendicular. This is a standard foot of the perpendicular question from a point to a plane. And the method again is something that we've been doing over and over again. You've probably done it quite 1,000 of times, right? So what's the first strategy? First one, we see there's number 1, we can try to find the equation of this line. This is the general idea. We find equation of this line. Okay, after that, we just intersect it with the equation of the plane. So remember, the equation of the plane is none other than r dot 2, negative 2, 1 equals to 4. Alright, first idea is this. Okay, since r, right, you can see it lies on the line, right? Okay, let's talk about the equation of this line. So what's the equation of this line? Let's say if I were to call this maybe line 1. What's the equation of this line? You can see that for this line, it is perpendicular to the plane. So the direction vector along this line should be none other than the normal of the plane, which is 2, negative 2, 1. Alright? And the equation for line 1, you can see it's just none other than 408 plus lambda. Sorry, maybe I should use lambda because lambda be used before. We can use alpha 2, negative 2, 1, where alpha is real. Alright, next, since R, right, you can see R, it lies on the line, right? You can say since R lies on the line, okay, so we can also say that your OR, right, satisfy, it can take the form of the equation of the line. Am I right? So OR lies on that. So we can say OR is equals to 4 plus 2 alpha, negative 2 alpha, and 8 plus alpha for some alpha, right? Real. Okay, so we can say this, right? Since OR lies on the line, it can take the form of the equation of the line. At the same time, OR also lies on the plane. Okay, so you can also satisfy the equation of the plane, right? So what we do is, let's say if I were to call this, we can actually basically substitute this, okay, the equation on the line into the plane, and we solve them simultaneously. Alright, at this point of intersection, OR satisfy both the equation of the line and the equation of the plane. Now recall, this is the equation of the plane. Alright, 2, negative 2, 1 equals to 4. Alright, and this basically refers to our XYZ, remember? So what we're going to do, this XYZ, we're going to sub in our 4 plus 2 alpha, and that's what I'm going to do. Okay, basically I sub in the equation of the line together into the plane. Alright, so solving this, what you should have, 8 plus 4 alpha plus 4 alpha plus 8 plus alpha equals to 4, and alpha will be equals to negative 4 over 3. Alright, and hence if you were to sub back in our alpha back here, we can find out the R. Alright, we can find out the OR, where OR is the position vector. Okay, it's actually the foot of the perpendicular from Q onto plane 1. Alright, so we just sub alpha equals to 4 over 3 into equation you have OR equals to 4 over 3, the Y component is 8 over 3 and 20 over 3. So basically you just sub alpha inside. Okay, and that is shown. Alright, there's another method that involves using the projection. Alright, so this is just another idea. I'm just going to quickly show through. I'm not going to go through it very in detail. First of all, since we have Q is 408. So basically this is method 2. There's another method for finding the okay, there's another method. So one is like this. Okay, so because the foot of the perpendicular is R, alright, there's another point on the plane, remember, which is a projection method. So it's 1, 5, 12, right? This is the point that lies on the plane. I can actually find this, right? And PQ, if you're able to find it, PQ is actually none other than 3, negative 5, negative 4. Okay, I can project this onto the unit vector of the normal. Alright, so if I were to find n hat is none other than 1 over square root 17, 2, negative 2, 1. Right, so if I can project this onto this, remember, I can project this onto this, alright, I can actually find out, okay, what is RQ. I can find out what is RQ. So RQ will be 8 over 3, negative 8 over 3, 4 over 3. And from RQ, you can then find OR. So I'm not going to show in detail here, but I hope you are able to do it. Okay, so you can try this out. This is the second method.